Okay, on our definition of a parallelogram, we know that opposite sides are parallel, but it turns out there's a lot more going on than just that. And in fact, in this lesson 6-3, in this lesson, we learn how we can test to see if something actually is a parallelogram. Okay? So the definition again, if each pair of opposite sides is parallel to each other, it is a parallelogram by definition. So if we're looking, for example, let me click right here. We're looking at this parallelogram or possible parallelogram that you have on your skills practice number 1. We have some things marked here, right? We can see that it is a quadrilateral, but then there's a couple of other markings. So do you guys know what the black triangles right here mean? They're going in the same direction. So when two sides of a parallelogram have triangles marked in them, what it means is that they are congruent, or I'm sorry, parallel to each other. So we know that this side is parallel to this side. And then you have these marks here, which we've talked about before. They mean that these sides have been measured and their lengths are equal. So they are congruent sides. So parallel, one pair of sides we know something about. We know they're parallel and we know they're congruent. But we don't know anything about the other pair of sides. So this could be a parallelogram. It might not be. Maybe it is something we call a trapezoid. Okay? Well, when we look at our rules, or rather our definition, we know that in order to be a parallelogram, it has to have both pairs of opposite sides. It says each pair of opposite sides has to be parallel. So that if we can prove that it's parallel, then we will also know that these sides here are also parallel to each other. But how can we prove it? So now we get into the test. Here we go. One test. If both opposite pairs are congruent to each other. So this AD and BC are both marked with a single pink line that you see here. That means that they are parallel to each other. Let me try to zoom in a little bit more. I'm sorry, not parallel. It means they are congruent to each other. So if they're congruent and both pairs are congruent, then it is a parallelogram. So there it is. They're calling it theorem 6.9. That 6.9 is just from this publisher only, because this is their chapter 6. But it's not all, that's not a universal number or code for all theorems for mathematicians, okay? Just these guys. But basically what it's saying is that if both pairs of opposite sides are congruent, then it is a parallelogram, okay? If I were you, I think what I would do here, let me get my highlighter, is I think I would highlight right, wait a minute, is this it? So that right there, that is something that I would want to know and remember. Both pairs of opposite sides of a quadrilateral are congruent. Then it has to be a parallelogram. Okay, here's another one. Okay, it says both pairs of opposite angles are congruent. So these angles across each other are marked congruent. These angles across each other are congruent. Here we go. The diagonals, oops, let me get my highlighter back. Diagonals of a quadrilateral bisect each other. So this half of this diagonal is equal to that half of that diagonal, and the same with this other one. So both pairs are bisecting each other. It's a parallelogram. And then here's the one that we need for this problem right here that we're working on right now. So if one pair is both congruent and parallel, so when you see that line and the arrow for congruent and parallel on one pair, then it is a parallelogram. By this theorem they call 6.12. So when I look at this assignment here, I see congruent and parallel. We're supposed to determine whether it is a parallelogram and justify our answer. All right. So I think what I would do is for this one, okay, let me get to my whiteboard here. Sorry, control me. Let me paste that there. I don't want that. Okay, so for example here, I would be saying my response would be this is a parallelogram because one pair of opposite sides is both congruent and parallel. How about in the case of number 2? Both pairs of opposite angles are congruent. So this is a parallelogram because both pairs of opposite angles are congruent. Right, they're marked congruent. Yeah, on this one, there's just not enough information to conclude it's a parallelogram if all we know is that one pair of opposite sides is parallel. I'm sorry, is congruent. That's not enough, okay? This could be a trapezoid. Let me draw a really, like an example. If I had a side like this, then a parallel side, let's say like this, then I connected them, and let's say this measured, I don't know, 9 units. And let's say this over here also measured 9 units. Well, I have one pair of opposite sides that are congruent to each other, but this is not a parallelogram because, well, it's maybe a trapezoid, right? If this side is, it's not enough, okay? Okay, and last but not least, out of these here, number 4. Here I have both pairs of opposite sides are congruent. That was our first one right here. If both pairs of opposite sides are congruent. So both pairs of opposite sides, both pairs of opposite angles, and one pair of sides and angle, or one pair of sides being congruent and parallel. That's what we've seen here. And so 3 of the 4 they showed to us. My guess is the other one's going to be on the other page. So here we go. This is a parallelogram because both pairs of opposite sides are congruent. Okay. Okay. Here we go, number 5. So they're asking me with this problem to prove whether or not this PQSY is a parallelogram using only my slope formula. I think I'll get my pencil out for this so I can do some work with it. Okay. So let's talk about the slope formula. Slope, we use M for slope. Oops. Let me get a different pen here real quick. Hold on. Undo, undo, get rid of that little M there. I don't know. See if I can get my eraser back. Where's my eraser? How about this? Okay, we got another pen. I'm going to make this a little bit smaller. That'll work. Okay, here we go. So the slope formula M is equal to y minus y over x minus x. So I've got to check these sides out and see whether or not this is a parallelogram. And the first thing I'm going to do is I'm going to actually plot this point so I can see which sides are which, right? And I think I'll use my calculator for this. So what I would do is I'll go to my calculator, add in a graph page. Then I'd use the menu, geometry, points and lines, and point menu. If I use my point menu, then I can just put in the coordinates they gave me. So P was at 0, 0, that's P. Q is at 3, 4. S is at 7, 4. And Y is at 4, 0. So here I have P, Q, Y, and S, okay? I'm going to go ahead and turn that into a parallelogram. Let me try that again. Menu, geometry, shapes, a polygon number 4. I don't know if this is a parallelogram, and I'm going to turn it into a quadrilateral. It might be a parallelogram. So what I want to do is I want to test this side here, the slope of this side to the slope of this side. So y minus y over x minus x. So if I did that, right, so that'd be 4. It looked like this. So it would look like if I'm doing these two right here, and this is x, and this is y, and this is x, and this is y, then I would go 4 minus 0, because those are my x, or my y's right there, over 3 minus 0, because those are my x's right here and right here. And if I reduce that, that just becomes 4 over 3. And then I would do it with the other 2 points here. You get another color for this. I think if I increase the thickness, that might be good too. Let me just try moving that back up to 4. Might make it a little more visible. So here we go. So I'm going to go to these 2. This is my X, this is my Y, this is my X, this is my Y, right? So I'm going to start with my Y, so I have 4 minus 0 over, now my X's, 7 minus 4, 7 minus 4. Well, 4 minus 0 is 4, and 7 minus 4 is 3. And since I see they have the same slope, then these 2 sides are parallel to each other. So let me do this. So what we just did proved that this side right here has a slope of 4 over 3. And this side also has a slope of 4 over 3. Is that enough to prove that it's a parallelogram? No. We've got to test the other sides as well, the slopes of the other sides. So that is 0, 0, and 4, 0. So we're gonna group these together. Let me get the colors here right. Another color. So let me go with this orange color. If I were to say, okay, what about 4, 0, and 0, 0? That's these 2, okay? Which is this side over here, right? So what's the slope of that side? So again, we have x and y and x and y. So I'm going to do the y minus y over the x minus x. And the y's are 0 minus 0 over, then I have 0 minus 4, 0 minus 4. And that's equal to 0 over negative 4, which is equal to a slope of 0. So that one has a slope of 0. Let's check the last one here. Here we go. Pick a, maybe a bright red and make it big like this, okay? So let's check these 2 out right here. QS, which would be this side right here, right? So we're going to do again y minus y. So that'd be 4 minus 4 over x minus x, 3 minus 7, which is equal to 0 over negative 4, which is equal to 0 again. Excuse me. So what we just proved is that this one has a slope of 0. I'm going to use 2 arrows here to show that the slope has been measured. And it has a slope of 0. And this side over here also has a slope of 0. Okay, so if both pairs are opposite sides, if both pairs of opposite sides have parallel lines or have the same slope, then this must be a parallelogram by the definition of a parallelogram. Okay, going to number 6. If you're following along, you'll have this all done and you won't have to do it anymore. Here we're going to use the distance and slope formulas. I'm going to get a new document going with the graph page and put in some points. I like to see them. For me, it's just helpful to see what they are. So this is -2, 1. So -2, enter 1, enter. And 1, 3. So 1, enter, 3, enter. Then 2, 0, 2, 0. And -1, -2. Oops. Get that. I lost my tool there. Menu, geometry, points and lines, and a point tool again. So it was -1, enter, -2. I think that was what I said. -1, -2. Yeah. Get my polygon tool out. So that is 8 point shapes and polygon number 4. The way to connect this is going to have to be going around like this. Okay. Grab this image here. Okay. So I've got that image, and then I was given this problem here, right? It's telling me to use the distance and the slope formula. So we're going to use the distance and the slope formula here. So let me write those formulas down real quick. Okay, let's say we'll go here. The distance formula is equal to the square root of x minus x squared plus y minus y squared. And then the slope formula is equal to y minus y over x minus x. And so I'm going to pick two sides to do this to. I think I'll pick this side right here. And then I think I will pick this side right over here. So I got two different sides I'm going to do. So let me go back. I'll start with this blue side right here. This is -1, -2, and 2, 0. So I'm going to calculate this in blue, the distance between square root sign -1 minus 2 squared plus -2 minus 0 squared. Okay, and I'm just taking -1 and 2. My x is here, -2 and 0. My y is there. Plugging it into that formula. -1 take away 2 is -3 squared, which is 9. Plus -2 take away 0 is -2 squared, which is +4. So all of that together equals the square root of 13. Now you can just use your calculator for that. But the distance here would be equal to the square root of 13. So you know what I'm going to do now? I'm going to do it again, only I'm going to use the green numbers here. That's this test using the green numbers. So it's going to be like this. The square root of x minus x, so that's -2 minus 1 squared, right? Plus y minus y, I have 1 minus 3, 1 minus 3, and the square of that. So -1 take away 2 is -3, and if I square that, I get 9. 1 minus 3 is negative 2. And if I square that, I get 4. Of course, all of this is the square root. We still have the square root sign there. If I add 9 and 4 together, I get 13 again. So the distance here is equal to root 13. This is also root 13. So I could use my marker and indicate that this side here and this side here have been measured and they are congruent. But they want me to now do my distance formulas, my slope formula over here. So that's going to be y minus y over x minus x. So let me go back to the blue. We'll start with the blue again. So y minus y, negative 2 minus 0. Negative 2 minus 0 over negative 1 minus 2. Negative 1 minus 2. Negative 2 take away 0 is negative 2. 1 take away 2, negative 1 take away 2 is negative 3. So this slope is positive 2 over 3. In other words, it goes over 2 and up 3. I don't know if that's right. I think it must be, right? Because it went over a total of 1, 2, 3. Went over 3 and it went up 2. Yeah, from negative 2 to 0. So it is a slope of 2/3. That is correct. Okay, let's do it with the green side, this green side over here. And we're going to do y minus y over x minus x. So we have 1 minus 3 on top over negative 2 minus 1, negative 2 minus 1. 1 minus 3 is negative 2. Negative 2 minus 1 is negative 3. And that's equal to a slope of positive 2/3. The negatives cancel. So we got the same slope here when we calculated it. Now let me show you, that's a lot of work to do for problem number 6, right? That took me probably, I don't know, 5 minutes or so at least. But some of the things that are helpful is, number one, if I just look at this problem and I see these letters and I don't do anything with these letters and coordinates, that's not going to make the problem any easier. So by putting it in the calculator, that really helped me. All right, I was able to put them in the calculator. Then I can see it. Then I can just pick two sides that I'm going to test. Right? That is extremely helpful. I'm not getting confused about which pairs to put together. And now, because I have one pair of sides that is both parallel and congruent, we can classify this. This is a, this is a parallelogram because one pair of opposite sides is both parallel and congruent. Okay? So this will be my answer, and this is my work that proves the answer. Okay? I have to show you this, or I wouldn't be a very good person, I don't think. If I were to draw a line, first of all, I can measure. Geometry, measurement. I can measure how long this side is. So let me hit tab. That side, that is the square root of 13 approximately. It's been rounded. If I press tab, I can measure this side. I can see that these two sides are the same. They are congruent. And I don't know if I can measure the slope unless I draw a line over it, which I know I can do, but let's see. Yeah, it won't. So if I draw a line on top of it, so I'll go geometry. Oh boy, try that again. That's why you don't want to click, because these things are funny. Points and lines, and number 5 is a line. So if I draw a line through these endpoints and a line through these endpoints, then I can use my geometry, measure the slope tool, and I can see, hey, there's 2/3, and this is also 2/3. So there's my confirmation. I did the work by hand. I did the slope formula by hand, but I also checked it on the calculator to make sure I didn't have any mistakes there. Okay, one more real quick, and then let's see the rest of this work. I'll do this midpoint formula. Let's do that one real quick. So here we go, menu. Let's see. Let me just get a new document. Let's just start this out new. You get a graph page, menu, geometry, points and lines, point. And I'm going to plot these points that they gave me for number 7, which is 2, 5, and 3, 3, and -2, -3, and -3, 1. Well, I can tell you just from looking at that, -3, 1, -2, -3, 3, 3, and 2, 5, sure doesn't look like a parallelogram. But they want us to prove it finding the midpoint of each side and see if it's bisecting each other. So let me show you how that would work. Let me construct the parallelogram here, or the possible parallelogram. Doesn't really look like one to me, and we're going to move these points where we have a clear view of the coordinates. Okay. Okay, so what they want to do is, again, check using the midpoint formula. So let me show you how this is actually not as bad as it looks. It's going to be, this one's a lot quicker than the others, and I'll help you understand why and how here in a second. Okay, so you might remember that the midpoint formula is done by adding the x's together and dividing in half, right? Then adding the y's together and dividing in half. But I'm going to show you which ones I need to connect. So from the yellow, I'm going to use yellow to show you one diagonal, and red to show you the other diagonal here. And then the idea is to find the midpoint of one and find the midpoint of the other. And if it's the same point, then it's a parallelogram. This is another way to do it, right? Because if it's the same point, then they bisect each other. So here's the midpoint formula. Let's start with the red. The midpoint formula is like this: x plus x over 2, y plus y over 2. And I'm going to do it between 3, 3 and -3, 1. So I'm checking the midpoint of these two right here. So -3 plus 3 over 2, right? -3 right here and +3 right there over 2. That would equal 0 over 2, which is just 0. So the midpoint of the red side is at 0 something, and then the y value is 1 plus 3, 1 plus 3 over 2, which is 4 over 2, which is 2. So 0 is 0, 2. So this would be the midpoint right there. Now we'll do it with the yellow side. So I'm going to be doing negative 2 and 2. So negative 2 plus 2 over 0. Well, that's 0. Oh, I'm sorry, over 2. So the formula says add the x's together and divide by 2. So I add the x's, divide by 2, and I get 0 divided by 2, which is 0. Then I add the y's, negative 3 and 5. So negative 3 plus 5 over 2. Negative 3 plus 5 is 2 over 2. And 2 over 2 is 1. So the midpoint of the yellow one is at 0, 1. And since these two are not the same midpoint, then they don't bisect each other. Right? They don't meet at exactly, they meet at exactly 1 point, but the 1 point where they meet at can't be the midpoint for both sides because the midpoints are different. So my answer here is going to say this is not a parallelogram because the diagonals do not intersect. Well, I'll use their language. They do not bisect each other, or they do not intersect at each other's midpoint. It's another way to say they do not bisect each other. Okay, it was just a few minutes. Then when I look here at these last problems, find x and y so that they're parallel. Well, we can just set these as equal to each other. And I'm going to actually not do all this work right this minute because I want to give you as much time as possible. But I will set it up so you can see how you could do that. Okay, so if this was a parallelogram, then these two sides would have to be congruent, and that would mean that 2y is equal to y plus 19. And also, these two sides would have to be congruent, which would mean 2x minus 8 has to be equal to x plus 16. So then what you would do is you would solve for x and you would solve for y. And when you get an actual point x and y that makes a value for x and a value for y that makes these true, once you've solved them, well then that would be your answer. That would make them equal. And you do the same thing here. I have these two angles. If this is a parallelogram, they have to be congruent. So 2y minus 5 would have to be equal to y plus 15. And then these two here, these two angles would have to be congruent. So 4x minus 35 would have to equal to 3x plus 10. Okay? So you'd solve for y and you'd solve for x. And of course, this looks a lot like it, right? So x plus 20 would have to equal 3x minus 14. And these two, 3y plus 2 would have to equal y plus 20. And then finally, this side would have to be congruent to this side. And this side here would have to be congruent to this side because they're supposed to bisect each other. So that means that 3x would have to equal 4x minus 3, and y plus 3 would have to equal 2y minus 11. Okay, I don't care if you use the solve command, whatever, but find the x and y values that make all these true, and that's how you would finish this work.